Welcome, everyone. My name is Juan Rogelio Tena Garcia. I am postdoctoral researcher from Simvestab, Zacatenco, in Mexico City. And I present to you my poster information of my poster of the research I collaborate. The research is called titanium, vanadium, chromium, manganese, high entropy alloy processed by high pressure torsion for hydrogen storage. And next, this is a brief introduction of the work. A nanostructure bulk material was fabricated from an arc melt. High entropy titanium, vanadium, chromium, manganese alloy by application of high pressure torsion. The microstructure of hydrogen storage response were evaluated. The microstructure of S-cast and HPT processed alloys consists of a mixture of BCC matrix and CO14 lattice phase. The hydrogen storage studies showed a first rapid hydrogenation absorption and at room temperature in S-cast and HPT processed alloys, and a total hydrogen storage capacity of almost 1.5%. A brief introduction: many high entropy alloys with heterodistinct properties have been studied since the pioneering works of the encounter. High creep resistance, a good combination of strength and ductility, and interesting hydrogen storage properties are among the features that have drawn extensive attention. Nanostructure high entropy alloys have been produced by high pressure torsion and superplastic deformation processes, which enables the application of huge amounts of plastic deformation. The process has been used to improve the kinetics of hydrogenation in several hydrogen storage materials. This work reports the effect of HPT processing on the first hydrogenation of a titanium, vanadium, chromium, manganese alloy. Materials and methods. Acyatomic titanium, vanadium, chromium, manganese alloy was prepared by arc melting. After processing by high pressure torsion to produce disc of 10 millimeters diameter and 1 millimeter thickness. Fast identification was realized by XRD. The structural refinements using the Riedel method were carried out using the MALT program. Chemical composition and microstructure were characterized by SEM and XEDS. The kinetics of hydrogenation, were measured in a Sievers effect. Hydrogenation and 10 and 25 bar hydrogen pressure at room temperature. Now, previous activation processes was carried out. Dehydrogenation steps were performed at different temperatures up to 400 degrees Celsius under vacuum. Pressure composition temperature isotherms PCT was measured at 45 degrees Celsius and hydrogen pressures up to 25 bar. XRD results shows that BCC and C14 lattice phases were identified in S-cast and HPT processed samples. The major phase was BCC in both conditions, about 98%. From Riedel refinement after the HPT process, the BCC and C14 phases showed an increase in microstrain. For crystalline side, BCC phase shows a reduction while C14 phases experiences a slight increases. This is a result of S-cast and HPT alloy process. Same phases, and the Riedel refinement data comparison shows a reduction of crystalline size in BCC phases, both. And and increases of mixed string. And same in EDS characterization, micrograph of the titanium magnetic chrome magnesium alloy processes by HPT show BCC phases or matrix and gray regions and C14 lattice phases and bright regions, and the results of average chemical composition of each phase shows a higher magnesium and titanium concentrations in C14 lattice phase, and BCC phase has a higher concentrations of vanadium and chromium. Hydrogenation and dehydrogenation kinetics shows that titanium magnetic chromium magnesium alloy processes by HPT begins hydrogenation without incubation time, unlike as-cast alloy, shows in this figure. As-cast alloy has an incubation period of about 15 minutes over 20. And unlike first hydrogenation, the hydrogenation curves of titanium magnetic chrome magnesium alloy processes by HPT with no incubation time. Okay? High temperature of dehydrogenation is required to complete desorption of the sample. BCT isotherm shows in case of HPT alloy has a maximum hydrogen absorption capacity of 1.4% at 45 degrees Celsius. Hydrogen absorption occurs at very low pressures, lower than the detection limit of the AQ. Yeah. Under 1 bar of hydrogen pressure. Finally, conclusions. As-cast and HPT processed titanium, palladium, chromium, magnesium alloys are conformed by mainly a BCC phase and a lesser proportions by a C14 lattice phase. Elemental contribution in the different phases is not uniform with a higher concentrations of vanadium and chromium in BCC phases and titanium and magnesium in C14 lattice phases. And first hydrogenation, the material showed a rapid hydrogenation uptake at room temperature. This is important, and moderate hydrogen pressure without previous activation. High temperature, at least 450 degrees Celsius, is necessary to complete hydrogen desorption. The HPT processes improve the hydrogenation kinetics of the alloy, generating hydrogen uptake without an incubation time. Finally, the acknowledgement of all collaborations, and thank you for your attention. See you later.